Hi, Math 12. So what we'll do now is we'll begin our third unit. You should have the notes package for this. So this is looking at polynomial functions. So let's get into what the definition is. So poly simply means many. And so a polynomial function is given in the format where you have a coefficient that has to be a real number. So that's what we call a. So it's a, and then you have the variable, which could be x, and an exponent that has to be an integer. Okay, which means that it has to be a whole number, and it can't be 0. Okay, so an example of a polynomial would be something like y equals 5x minus 3, or y equals x cubed minus 6x squared minus 3x plus 2. So notice when we write down a polynomial, we always want to put the exponent in a descending order in terms of how big the exponent is, right? So you start with the biggest exponent and work your way down. So let's look at some examples here. Whether or not these are polynomial, and then what we'll also talk about is what we mean by degree, leading coefficient, and constant term. Okay, so let's look at the first one. So is this a polynomial function? The answer is no, because here you've got x to the power of minus 1. So if you go back to your description, you have to have the exponent n has to be positive because it's an integer. Let's look at the next one. So this one would be yes. Okay, so now let's get into what these terms mean. So what is degree? Degree has to do with the biggest power. So this one here would be a degree equal to 5. Okay, and then the leading coefficient is the coefficient that is attached to the biggest exponent. So in this case, so even though it's not written in the proper sequence, the x5 term should go first. Here your leading coefficient is going to equal minus 2. Okay, and then the constant term is a term that's not attached to a variable, so it's simply by itself. So meaning if x were to be 0, this would be what's left over. So your constant term here is going to be equal to 4. Okay, let's do the next one here. So here for C, let's put the answers here. Your degree is going to be 4. Okay, so it's going to be 4 because of the negative 4x to the power of 4. Your leading coefficient will be minus 4, because that's the coefficient that goes in front of that, and your constant term would be 3. Okay, and so that would also be a polynomial function. And then D is not a polynomial function because 1/2 is not a whole number. Okay, let's get to the next section. So here we can start looking at the different types of shapes you can get with polynomial functions. So the first one there is degree 0. Okay, so degree 0 means that you don't have any anything tied to an x term. So like this one here, an example of this would be something like x equal to 7. So that's what would get you a horizontal line. So it's pure constant. Now when we talk about some of the terms that we're going to get into, so let's look at one of the terms we're going to talk about is what we call end behavior. So end behavior of the graph is basically talking about where the graph is going. So like for that first one there, the end behavior for the degree 0 would be that the line extends horizontally. Okay, let's look at the next one here. So this is a linear. So this is like your y equals mx plus b. So now when we talk about some of the aspects of the graph, we'll connect that to the grid. And the grid, remember, has 4 quadrants. So this is quadrant 1, 2, 3, and 4. Okay, so notice it goes counterclockwise. So if we were to talk about how the linear function, so this is a positive linear function in this case, what we would say is that it goes up quadrant 1 and it goes down quadrant 3. So that's the way we can describe the behavior of that one. A quadratic function, degree 2, so that there's your parabola. So you can have a multitude of intercepts, so there could be 0, 1, or 2 x-intercepts for that. And then you've got your cubic, your quartic degree 4, and your quintic degree 5. So we'll come back to those in just a bit here. So let's take this one here. So we want to describe the end behavior. We want to talk about the possible number of x-intercepts, so like, and the y-intercept, and whether the graph has a maximum or minimum value. So a maximum means that it would be opening down. A minimum means that it would be opening up if it's like say a parabola. Okay, and it doesn't necessarily have to have either of those, a maximum or minimum, because it could keep going in both directions. So what you want to do in order for to look at the function, first thing you want to look at is, of those 6 shapes that we looked at the top, where does this belong? And the way you look at that is by the biggest exponent. So here you've got an exponent of 3, so that tells you this is cubic. Okay, so it's a cubic. It's got a degree of 3. Okay, so now we can go up. So you should be pretty familiar with these shapes. So if it's a cubic function, you're always going to have at least one intercept. Okay, so remember that we're just looking at sort of a base function there, so you can move that up or down or sideways or whatever. So in terms of the x-intercepts here, you're going to have 1, 2, or 3. Okay. The y-intercept is going to be 1, so there'll only be one y-intercept. And now, how do we know which way the graph is going? So there's your leading coefficient. It's negative. Okay, so if the leading coefficient is negative, then one way that we can help figure out how this this graph is behaving is that if you're talking about a cubic, which is odd, and it's negative, then what's going to happen here is this is going to follow similarly to y equals negative x. Okay, so that is to say that the behavior of this cubic function will sort of mimic y equals negative x. So what that tells you is the end behavior is going to be, so again, go back to the shape. So the end behavior here is going to be quadrant 2. Quadrant 2 and quadrant 4. Okay, so just like a y equals negative x would go, right? So like a y equals negative x would be something like some line like that. Okay, and then in terms of there's maximum and minimum, there is for this graph no max or minimum. Okay, so those are different characteristics you can you can figure out from the graph. Okay, lastly, let's look at some calculations here. So here's your function, right? So you notice you don't always have to use x. So it could be using different letters, but you still treat this the same way. And so when it says solve for v8, okay, so what that's telling you is find out what the function is equivalent to when 8 is substituted for h. Okay, so h equals 8 in this case, right? So you put h equals 8. So you got 8 cubed plus 10 times 8 squared plus 31 times 8 plus 30. Okay, so you work that out. And that gives you 1430 as your answer. Now you can also figure this out graphically. So using Desmos. Okay, so let's have a look at that. So again, you should be familiar with the app. Hopefully, you've had a chance to use it. So so now we don't have to use the h. Okay, so what we'll do here is instead of v, I'll just call this y. Okay, and so we got y equals x. Okay, so now we want to use cube, and you notice there's no there's a square, but there's no cube. So you press that A to the 8 button, A to the B button, and we can put a 3 there. Okay, and then you press it again. So sorry, just what I do here. Okay, so there's your x cubed, and then we want to get that. Okay, so there's a sort of a cubic function right there. Okay, there we go. So there's x cubed. Whoops. And then we want to go plus, and then we've got 10x squared, and then plus 31x, and then plus 30. Okay, so what we want to do is we want to figure out what, so we're using y and x instead of v and h, right? So we want to figure out what is v, what is y going to be when x is 8. Okay, so we got to follow this graph. So remember, you can zoom in and zoom out. And so anywhere along the graph here, so notice here, I'm basically just using my finger and working, I need to be going up, sorry. No, that was x equals 8. Okay, so we got x cubed plus 10x squared plus 31x plus 30, and we're looking for, oh, I was looking on the wrong side there. Okay, so let's look on the other side. So you can kind of focus in on a section, and then you can zoom in on that section. So now if I, okay, so there we go. We're working our way closer to 8. And there we are, right? So there it is. Okay, so at 8 is 1430. So you can find the answer that way as well. using the technology. Okay. So again, hopefully you've had a chance to look at that. Okay, so I'll stop there. So you can work on the questions tied into the first section here of Unit 3. Okay.